Hello dear students, in this lecture we are going to discuss about density, relative density and Archimedes principles and how the density and upthrust of the liquid related to each other. So please like, comment and share these videos and also watch these videos until end and spread the knowledge in our society. Thank you. Let me give a start to it. So density, the mass per unit volume is called density of the substance. We know that all the substance in this universe, in this nature, is made by atoms and molecules, smallest particles, atoms or molecules. So density is the total number of molecules within unit or unit volume or 1 cubic meter volume. So how many number of molecules or atoms of the substance are there in 1 cubic meter volume? That is the density of the substance. And its SI unit is its mathematically its formula is density is equal to density D is equal to mass M by volume V, and we know that mass is measured in kilogram and volume in cubic meter. So its SI unit is the SI unit of density is kilogram per cubic meter, and its CGS unit is gram per cubic centimeter. And different objects have different density, their own densities. Densities differ according to different substance. Now go to relative density. Relative density. Relative density. By the word relative, it means we are going to compare one with another. Relative means comparing of one with another. So here we compare a substance is how much heavier than another substance, or that is called density. Or mainly we compare the density of one substance with the density of pure water at 4 degrees Celsius, means a substance is how much heavier than pure water at 4 degrees centigrade temperature. That is called relative density. So it is the ratio of the density of a substance substance to the density of pure water at 4 degrees centigrade. At 4 degrees centigrade is called relative density. Is called relative density. It is also called as specific gravity. It is also called as specific gravity. So don't be confused in relative density and specific gravity. specific gravity. It is also called specific gravity, and it has no unit. One point is it has no unit. Why? Do you know? It has no unit because it is the ratio of same quantity, that is density. It has no unit because it is the ratio of same quantity. That's why it has no unit. It is unitless. Its formula is RD is equal to relative density is equal to density of substance, density of the given substance to the density of pure water at 4 degrees centigrade. Density of pure water at 4 degree centigrade, that is 1000 density of water at pure degree centigrades. Now, and it has, let me keep in a box. Now two main points are 1000 kg per cubic meter. It is density of pure water at 4 degrees centigrade in SI system. So two main points are here. In CGS system, CGS means it is the system of measurement. CGS system, the density of the given substance, substance without unit is equal to relative density of that substance. Secondly, what is the relation between density and upthrust of the liquid? So the thrust or upthrust given by liquid is directly proportional to its density. Means greater the density of the substance, higher will be the upthrust given by it. Sorry, greater the density of the given liquid will be higher the upthrust given by it. So regarding this, one give reason is here, like an egg can sink in pure water, but it float in concentrated salt saturated solution, or water having high concentration of salt or salty water. Why? So here in pure water has less density than that of salt saturated solution. So less the density, less the upthrust, and more the density, greater the upthrust given by the liquid. The pure water has less density, so it gives less upthrust to the egg, and density of the egg is comparatively higher than the density of the pure water. That's why an egg sinks easily in pure water, but it floats in a salt solution or salt saturated solution, because density of an egg is less than the density of the salt saturated solution. Now go to Archimedes' principle. Archimedes' principle. This principle was proposed by a Greek philosopher, and his name was Archimedes. One day, about 2200 years ago, one day he went for a bath, and when he entered a bathtub full of water, then the water overflow from fell down from the bathtub, and he felt lighter than earlier when he was outside the bathtub. Means he experiences his weight, there is loss in his weight, and he found that some water from the bathtub flew outside, overflew outside the bathtub, and he proposed that, and after getting a conclusion, he proposed a principle, that is Archimedes' principle. Means it states that when a body is it states that sorry which pen I used it states that when a body is immersed partially or completely in a liquid, or completely in a liquid, then an upthrust is experienced by the body, object. Here I have written the object or body is object or body, due to liquid which is equal to the weight of the displaced liquid. He found that the amount of liquid that is displaced by him was equal to the upthrust or the weight he lost when he was in bathtub full of water. So when you immersed an object partially or completely in a liquid, then the object displaces the liquid and occupy the space of that liquid, and the weight of that displaced liquid by the object becomes or becomes equal to the upthrust that is being experienced by the object when it is inside the liquid, either partially or completely immersed. So upthrust is equal to upthrust U is equal to weight of the displaced liquid. Displaced liquid W, or U is equal to mg, means that displaced liquid has certain mass, and at that place is its weight, the weight of that displaced liquid is mg. So remember this. And another, he found that next point was the volume of the displaced liquid. The volume of the displaced liquid is equal to volume of the immersed part of the object, means the fraction of the total volume of the object that is inside the water, means under the surface of the water, that is equal to the volume of the displaced liquid by that object. So these are the 2 points on which you have to focus. Now go for theoretical proof. How can you prove theoretically? So here a cylinder, this is a cylinder having 2 ends, one upper end denoted by x and lower end is denoted by, lower face is denoted by y, and it has cross sectional area capital A, and its height is h. Height of cylinder is h. When this cylinder is immersed completely in the liquid, this liquid may be water, whatever, but it is liquid, okay? So it is completely immersed in the liquid. When it is immersed, it experiences pressure by the liquid from its all sides, on its all sides. प्रत्येक यसले आफ्नो पूरी सतहमा लिक्विडले एक्जर्ट गरेको प्रेसरलाई एक्सपिरियन्स गर्छ हैन. So here 3 lines, that is acting laterally, 3 red arrows acting laterally from both sides, right and left, are acting opposite in direction, and this pressure, the pressure by the liquid at a point or at the same level is always equal, and these pressure are equal to each other, and these are acting at same point in opposite direction. That's why this lateral pressure given by the liquid will cancel out. Its resultant will be 0. While on the upper face, that is x face, 2 line represents the pressure by the liquid in downward direction, which is at height h1 or depth h1 from the surface of the liquid, and the lower end or lower face y is at depth h2 from the free surface of the liquid, and at this face, y face of the cylinder, it experiences an upward pressure or thrust by the liquid, which is greater, because we know that greater the depth, more the depth of the liquid, greater the pressure or the thrust given by the pressure given by the liquid. So let me write it. Let us suppose a cylinder of cross sectional area A and height h is completely immersed in the liquid. In the figure you can see two lateral pressure. The lateral pressure from both face or both sides, pressure acting horizontally on both sides are equal but acting opposite in direction. Equal but acting in opposite direction. So these are cancelled. These are cancelled by each other. Now, but cancelled by each other. But let the upper face x of the cylinder is at depth h1 and lower face, you can say also lower face, that is y, is at depth h2 from the free surface of the liquid. So the liquid exerts thrust. So the thrust at upper end or upper face, that is x, due to liquid is F1 is equal to pressure into area. Pressure into area, and at F1 is at thrust F1 is acting at x face, upper face, and that upper face x is at depth h1 from the free surface. So it is P1 into a pressure P1 and or F1 is equal to P1 is D density of the liquid, G and H1 into area. Equation 1 we have from here. Reason is pressure of liquid or pressure given by liquid is always equal to HdG. Let me turn the page. Similarly, the thrust at lower end or lower face Y of the cylinder due to liquid is F2 is equal to pressure into area. Area is here same, pressure P2 into A, or F2 is equal to pressure at lower end or lower face Y, and which is at depth H2 from the free surface of the liquid. So pressure is dg H2 into A. Equation 2. Now the net, and there is two pressure acting on the liquid, two different pressure at upper end and lower end or face, and there is a upward, there is net thrust given by the liquid on the cylinder. That is, therefore the net means resultant, the net upward thrust on the cylinder is F2 minus F1 is equal to dg H2 into A minus dg H1 into A, and this F2 minus F1 is of thrust U, which is equal to dg A H2 minus H1. Reason here F2 minus F1 is equal to of thrust, or U is equal to dg V. Reason is H2 minus H1 is equal to H, height of the cylinder, and volume is equal to area into height. So this is the factors that affects or the thrust of the liquid affected by different factors. Factors on which of thrust of the liquid depends are, what are that? Number one is the volume of the liquid, the volume of the body, means what volume of the body is inside the water or the liquid, that is V. So upthrust is directly proportional to V. Number two is density of the liquid, that is D. So upthrust is also directly proportional to density of the liquid. And finally third one is acceleration due to gravity of that place. Acceleration due to gravity G. So U is also directly proportional to G. So of thrust is equal to weight of the displaced liquid, and volume of the part of the body which is inside the liquid is equal to volume of the liquid displaced by that part of the body. So I'm going to give some questions. Some questions are to practice. Questions for practice are: number 1, what is density? What is density? Write its SI and CGS unit with formula. Second one is, what is a specific gravity? What is a specific gravity? And why is it unitless quantity? Third one is, states Archimedes principle. States and prove Archimedes principle. Fourth one is, the weight of a body. Weight of a body is less in water than in air. Why? Thank you. Watch this till the end and also share to your friends. Thank you.